So your first thing you need to do is edit this 5.3. It's actually 8.3. I think I'm stuck in the land of Unit 5. We're in Unit 8 now. So 8.3, we're multiplying and dividing polynomials. Very similar to the concepts that you just learned in simplifying your rational expressions. It says polynomials. Again, it's not polynomials, it's rational expressions. I really was in Unit 5. Rational expressions. All right, like you learned in 8.1 notes, rational expression, fancy way of saying fraction. So we're going to do some things here to make these look a lot simpler. So if you recall, when you multiply fractions, so say we had something like 5/7 over times 4/5, you could look at along the diagonal and reduce based on common factors. So we could go, oh, 5 and 5. Those have a common factor of 5. They cancel. They simplify to 1. And so 1 times 4, numerator times numerator is 4. This also reduced to a 1. So 7 times 1 is 7. So your final answer would be 4/7. Applying that same, then that concept is called cross reduce. So the first one's interesting. If you look at the r squared plus 5r minus 24, notice also there's an r squared plus 5r minus 24 on the diagonal, so we can cancel those out. Leaving us with, this is a 1. 1 times 5 is 5 over r minus 3. So the thing I really like about this concept is it's like a puzzle. So you're literally factoring things, so kind of breaking them down. In future questions we'll see that. And then you're canceling a bunch of things out, and it makes a much simpler expression. Number 2, sort of similar to number 1, the p squared plus 5p plus 6 is common along the diagonal, so I'm going to cancel those out. Nothing else cancels out. And we're left with p minus 6 over p plus 7. Number 3. All right, number 3, we have something that looks very similar, but not quite. So the 27 minus 21v and the 21v minus 27 would be the same if they just could flip around. So if you recall from our notes from 8.1, we can flip this around by factoring out a -1 and making that a 21v minus 27. And so now we look along the diagonal, we can cancel those out now. The -1 is still here, so now we're doing 7 times -1 is -7. And over 8v. Number 4, we get more into the factoring. We do see the a plus 9s could cancel out right away, but I'm going to factor everything first. So 5 could be factored out of the first numerator, leaving me with a minus 5. In the second denominator, we could factor that. Make my little factor tree, -45 over here, 4 over here. Two numbers that multiply to get -45 and add to get 4. 9 and 5, which one's negative? The 5. And that works out. So we're going to write this as a plus 9, a minus 5. And now we look to reduce. So the a plus 9s, I'm going to go ahead and cancel those out. The a minus 5s, and that's about it. So what's left in the numerator? Just the 5, right? 5. And then the denominator is just a plus 9. So we went from that whole thing down to this simplified version.
Could
Yes?
you not take that extra a plus 9 and factor that down too, because there's 3 of them now.
Yeah, so there has to be an even number. Like,
Gotcha.
they have to have a pair to cancel.
Gotcha.
I'll leave that for a second. Guys, mind if I just go ahead and finish the front for you? Is that okay?
Mhm.
Any objections? Okay. Help get stuck in your head. Number 5, we'll factor out the 4 from the 4p plus 20. Factor that out. So kind of replace that. And now we can look for our common factors. So we're at 4 and 4. That's within one fraction. We can reduce that way as well. That's our more common way to reduce. And then nothing else in common, so we're going to just have a p plus 5 in the numerator and a 3p in the denominator. Oh, I'm all the way down there. Number 6. Ready? Number 6. Greatest common factor here is 8. Leaving with n minus 10. That's all I can factor. Now I'm looking to reduce the 8s. Cancel out. The n minus 10s. Cancel out. And I'm left with
2.
2. That's it. Way simpler.
It is like a puzzle.
Yeah. Yeah. I can't, it's not like my easy ones here where I could just cancel those trinomials out altogether. So I have to, again, factor 2 numbers that multiply to get 9, add to get negative 6. What are they? Negative.
Negative 3 and negative 3.
You got it. So it's going to be v minus 3, v minus 3. Now here in the denominator, or second denominator, I want to factor out a negative 1 to start because I would rather that lead coefficient be a 1. Then I'm at a level 1 factoring, much easier than the level 3 factorings we've done. So if I factor out a negative 1, it just makes everything have the opposite sign. And then I'm just looking for my 2 numbers that multiply to get 6 and add to get negative 5.
6 and 1. Or that'd be negative 1. Or negative 6, 1.
Negative 6 times 1, that multiplies to get negative 6. So they both have to be negative, which would be negative 7. So that one didn't work. Any other ideas?
3 and 2.
3 and 2. Making them both negative will add up to negative 5. Good. So keep that negative 1 out front. We'll factor this into v minus 3, v minus 2. This goes away, this goes away. Super important. Okay, what's in the numerator? This part right here. And this part's in the denominator. So we're going to look to reduce. Ooh, what can we do here? We could flip those around if we factored out a negative 1. So that becomes v minus 3. So I can cancel out a v minus 3 here. I can cancel out a v minus 3 here. Anything else? We're actually going to multiply those since those are on the same level. But it kind of does wind up being a positive 1, which kind of cancels out. So numerator times numerator, we just have a 10 left over. Denominator times denominator, negative 1 times negative 1 is positive 1. And then v minus 2 is left. The last one, lots of 8s for number 8. 8n squared factors out, leaving us with n minus 1. And another 8n squared factors out, leaving us with n plus 1. Eight n squareds cancel. n minus 1 times 1 is just n minus 1. And then we've got the 3 times the n plus 1. And that's your final answer. So you go multiplying and dividing rational expressions. So far we've just been multiplying. So I want you to go ahead and practice the next 4 questions on the back that are multiplying rational expressions.
Four is the back.